14th June GFG question, symmetric tree. It's a very simple question. We are given a tree and you have to return true or false based on whether the left one is a mirror image of the right one. So like suppose here there is a mirror and this is the left part of the root. So this left children is here too, right? It's reflected. This 3 is reflected here. It should be here if we have to check whether the left subtree and right subtree are equal, same. But they're not same, they're mirrored. So that is why the left child of node 2 becomes the right child of node 2 in the mirrored one, right? Similarly, the right child becomes the left child. That is the only observation you have to make, and that is enough for the code. Like I've extended it. You can see even if there is further nodes 5, 6, 7, 8 and they're mirrored. So the left child of 3 is 5. Here the right child, it becomes the right child. And similarly, the right child of 3 is 6 and here it becomes the left child of 3. So we just have to code this. Now how can you code it? First of all, it is not compulsory that the structure would be given as equal, right? Suppose here are 5, 6 and here are null nodes and here are 8, 7, right? They can give anything in the question. So we have to first take care of the base case. The base case can be like, you have to check. First of all, we will use a helper function where we will give two nodes, a left subtree and a right subtree, and we will recursively check for these nodes. So first, suppose if left is null or right is null, then what can we do? Do we return true or do we return false? So if both are null at the same time, that is not an issue. So we return actually left is equals to right. So if any of this is null, this condition will trigger, and both of them has to be null. Otherwise, if only left is null or only right is null, it will return false. You can also write two statements like if not left and not right, then you return true. If not left or not right, then you return false, right? Similarly, but you can also write like this, left equal right. That will function exactly the same. This is the first thing that we have to do. Now, second, we have to check for values, like the value of this left node, the left part that we are traversing, should be equal to the right part. If it is not equal, we return the false value, okay? And in the last, we again recursively go as deep as possible. It's like kind of a DFS traversal. So what you have to check for is, you call this helper function for two things. First, for the left part, suppose the left part is having the node this 2, right? This 2 is the left part and this 2 is the right part, okay? So what we have to check? We have to check that left of left should be equal to what? Should be equal to right of right. And also, along with that, we have to check that left, the part of the left node, and right child should be equal to the right of left. So basically we are telling that this tree, the following tree, this entire tree 3, 5, 6 should be equal to this one, and this thing should be equal to this one. That is how we will recursively check and go as deep as possible, and this basically function will return our answer as either true or false. So that is exactly what I've written here. These are the three statements that I told you, and this is where we are just calling our helper function.